Hello and very good evening to all of you. Welcome to Resultant AJ YouTube channel, and I'm Vikas Udaria. I welcome you all to the session on the series on Game Changer, which is a series for RRB JE. And yesterday I have taken the subject of thermodynamics. Today we are going to study the topic of fluid mechanics. See, fluid mechanics is a very important subject. If we talk about mechanical and civil branch students, this is a common subject for both the branches, and so if anyone is preparing for RRB JE and or SSC JE CBT2 or any technical examination where fluid mechanics is an important subject or it is having a good weightage, then you can definitely follow these classes. Hi Vasant Reddy, good evening, welcome to the session. So good evening everyone, welcome to this session. Hope all of you are doing fine, and welcome to Resultant AJ YouTube channel. I'm your faculty and my name is Vikas Udaria, and I will be taking this subject of fluid mechanics today. And please everyone quickly follow me for this session, and those who have joined me for this session, also do not forget to like and share the session. Yeah. Hi Rajkumar, good evening, welcome to a session. So let's begin today's session, and let's start with, first of all, those who have joined me for the first time, those who are watching this video for the first time on this YouTube channel, I hope you have subscribed the YouTube channel. If not, please do subscribe the channel. Also, do not forget to like and share the video. Let me quickly cover a quick introduction of myself. My name is Vikas Bhadoria, and I'm a faculty of Mechanical Engineering branch, but for the subject of fluid mechanics, I will be teaching you the subject, and which is important for civil branch as well. I have a total experience of 7+ years. I have been teaching from the last 7+ years for different examinations like GATE, Engineering Services, SSC JE, and many other exams. Yeah, I'm fine, Rajkumar. How are you? So I have total 7+ year experience. I have taught the subject of fluid mechanics, thermodynamics, applied thermodynamics from the last 7 years. And I have done my MTech in thermal engineering because I am from mechanical background. I have done my master's in thermal engineering from Thapar University after qualifying the GATE examination. And I don't want to mention it here, but I have qualified GATE many times in 2013, 14, 15, 17, and 19. So these are the year in which I have qualified the GATE examination. But qualifying the GATE examination is not something which I feel so proud of that I have to tell something, because just qualifying an exam is not important. If I would have got a good PSU, then I would have been very proud of that. But anyways, so these are my qualification. Now quickly telling you about our courses. RRB JE 2024. We all faculties, you can see the faculties of mechanical, starting with Hira Sardana sir. And just a second. I hope my audio and video is fine. Is there any internet issue or any network issue? Please tell me. Hi Vasant sir, which date start class in app? Vasant Reddy, the classes in the app will be started from 12th, okay, from 12th of August. Pushpin, good evening. Saurabh, good evening. Prisma, good evening. Sir, RRB JE exam expected month क्या हो सकता है? Saurabh, expected month for this CBT one will be October month, maybe end of October. Just give me 1 second, let me just check the internet. I think it is fine. I hope there is no buffering issue. Is there any buffering issue? Yes, just let me know in the comment box if there any kind of buffering issue. Yeah, please. Just a second, let me just check at my end also. Okay, all right. Everything is fine. Okay, I guess it is fine now. Hello Anji Barsa, good evening, welcome to the session. All right, moving on, I have to tell you about a very important thing about our batches for RRB JE. So recently we have launched 3 types of batches for RRB JE, and we'd like to show you that. One is RRB JE, one is called focus batch, which is especially for, just a second. Yeah. So this is specially for RRB JE CBT1. The cost of the batch MRP price is 4,999, but offer price right now, if you buy the course, it will be just 2,499. Okay, initial those students who will buy the course, it will be just at 2,499. The second batch we have is RRB JE batch for CBT2, only CBT2, that is called AIM batch. It is for civil and mechanical branch. The MRP price is 5,999, but initially we are offering a discount, and this will be available at a price of 3,999. Also, we have a combined batch for CBT1 and CBT2, which is called Mission batch for civil and mechanical. The MRP price is, you can see, approximately 10,000, but it is just half right now. Okay, so those who want to join these batches, you can just call this number. You can see the number at the bottom, 79913100416, or you can also mail us here, support@resultant.in. Okay, so this is the information. In this AIM batch, will be providing you live and recorded classes in English. This is especially in English. And hello Puneet, good evening. And here we'll also providing you previous year question solution, quiz, test series and doubt session. Mission batch, same thing will be provided, but that is for CBT1 and CBT2 both. Okay, so let's come to question number 1 for fluid mechanics subject. Question number 1. So here you can see different forms of Bernoulli equations are given. Option A, option B and option C. In these three options, different forms of Bernoulli equations are given. You have to match. Okay, you know that Bernoulli equation is nothing but energy equation. Okay, it is also called as energy equation, right? Where different types of energies are given: pressure energy, potential energy and kinetic energy. So these are given in terms of energy per unit volume, per unit mass and per unit weight. Just match these different forms of Bernoulli equation and tell out of the three given equation what is W. W here means specific weight. I hope you know that. It determines specific weight. What is specific weight? Weight per unit volume, that is weight per unit volume, which is equal to rho into G. So in this equation you can see W is that. Okay, hello, it's good evening, welcome to the session. So you can see these three form of equations are given. What will be the right answer? Come on, tell me everyone. Bernoulli equation, energy per unit volume. Energy per unit volume is, this is the equation for energy per unit volume, that is A will be 1. Okay, this is the right answer. B is the equation which is called as, so if you remember what is the Bernoulli equation? Bernoulli equation is P by rho G plus Z plus V square by 2G is equal to constant. This is the energy equation per unit specific weight. Per unit specific weight, this is the equation. Okay. Okay. So this is the equation which is mentioned over here. This is energy per unit specific weight. Okay. This is energy per unit mass and this is the energy per unit volume. Clear? So option A will be the right answer. Clear to everyone? Hello Pallav Sarkar, good evening, welcome to a session. So option A will be the right answer. This different form of Bernoulli equation. This is the energy equation which contains pressure energy, kinetic energy and potential energy. Okay, different forms. Clear? Next है Darcy-Weisbach equation for the head loss in a flow through a pipe is given by this equation. This is Darcy-Weisbach equation, and with the help of this equation you can find the total head loss, which is the major head loss. Major head loss which comprise of, why the head loss take place? Major head loss comprises of 90%, 95% they have weightage. Okay, and because of friction in the pipe. So whenever a flow takes place in a pipe because of friction, the major head loss take place, and that can be calculated by Darcy-Weisbach equation and also one more equation which is called Chezy's equation. Now with respect to this question, they are asking for the laminar flow through a circular pipe, how does the friction coefficient F vary with a Reynolds number? Now they are asking about friction coefficient, they are not asking about friction factor. So there are two things here you need to understand. Darcy-Weisbach equation is, one is this, FL V square by 2GD, and one equation is 4FL V square by 2GD. Now most of the students get confused in these two equations. Let me tell you, both are written as F, but actually this F is called as friction coefficient. Friction coefficient, also called as fanning coefficient. Sometimes in some books you will find fanning coefficient. Yeah, fanning factor. And this is called as friction factor. It's called as friction factor. Clear to everyone? Now if they are asking about friction coefficient, so for laminar flow, friction factor is equal to 64 by Reynolds number, and this fanning factor is equal to 16 by Reynolds number. So the right answer will be option number B, because they are asking about friction coefficient. This is friction coefficient. Friction coefficient or fanning factor, this is F, which is equal to 16 by Reynolds number. Which faculty will be taking production? Puneet, production will be taken by Dheeraj Sardana sir. Okay, Dheeraj Sardana sir is having vast experience in teaching for mechanical engineering subjects, and particularly production subject will be taken by him. Okay, next is, how is the von Karman momentum integral equation expressed in terms of momentum thickness? Momentum thickness के form में how you represent the von Karman momentum integral equation. So hope you know this equation. With the help of this equation, Vasant Reddy industrial engineering will be taught by Suraj Gopi sir. Okay, you must have watched Suraj sir lecture. So Suraj Gopi sir will be taking the subject of industrial, and Dheeraj Sardana sir will be taking the subject of production. Okay, so the right answer for this question is, come on, I hope you have seen the von Karman momentum integral equation. This is tau naught. Tau naught is, it is wall shear stress. Yes, very good. Wall shear stress. Theta is the momentum thickness. You know what is theta, right? So what is theta? Theta is equal to 0 to delta of u by u infinity, which is the velocity profile, 1 minus u by u infinity, which is the velocity profile, dy. This is called momentum thickness. U naught is this is the free stream velocity. This is called as free stream velocity. You need to understand each and every term. Okay, free stream velocity, and rho is the density. So this is a equation which is called as von Karman momentum integral equation. Next is, a centrifugal pump delivers water at a rate of 50 liter per second. A centrifugal pump delivers water at a rate of 50 liter per second against a total head of 40 meter. Okay, then the power required to drive the pump is, what is the power required to drive the pump? Come on, and everyone tell me. Yes, everyone, please focus. This is a practice session for fluid mechanics subject, and if you follow this class, see, I will be taking this subject of fluid mechanics and thermodynamics, applied thermodynamics. Okay, so how you find the power required to drive the pump? See, you know that it is a centrifugal pump, and obviously it will be delivering water, right? So water power will be power required to drive the pump is equal to rho g q into h. Now this is a formula, but you have to find in kilowatt. So in kilowatt, to find it in kilowatt, you have to divide by 1000, then you will get the answer in kilowatt. Okay, if you don't divide by kilowatt, you will get the answer in watt. Okay, now sorry, 1000. If you don't divide by 1000, you will get the answer in watt. So this is rho, and rho is for water is equal to 1000. You know that it is for water, it is 1000 kg per meter cube. So this will get cancel out. So you will get it as GQH. What is G? 9.81. Q is equal to 50 liter per second, which you have to convert into meter per second, meter cube per second. So this will, you will get as power will be equal to 9.81 into 50 into 10 की power minus 3 into 40, and you will get the answer 19.6 kilowatt. Are you getting this value? Yes, very good. Option C is the right answer. Prisma Pushpendra. Very good. What about other students? Have you solved this question? For CBT2 of SSC JE and for CBT2 of RRB JE, the question level will be like this, where you have to use calculator. So if we do not solve this kind of numerical, that means we are actually not practicing as per the level of the exam, right? So theory questions will be easy, but what about the numerical questions? So we have to solve this kind of numerical question also. Bernoulli equation is derived by making which of one of the following assumptions? So you know Bernoulli equation, we have just studied the Bernoulli equation, which is pressure energy per unit specific weight plus kinetic energy per unit specific weight plus potential energy per unit specific weight. Sum of all these energies is equal to constant. That is your Bernoulli equation. But while deriving the Bernoulli equation, what assumptions we have taken? The assumptions we have taken is, the main assumption is that we have to take the fluid as steady flow, right? What is the meaning of steady? So when we say steady flow, that means the flow parameters do not change with time. Do not change with time. Whatever factors we are taking, whatever properties we are taking, we say that these properties do not change with time. Time independent, right? Flow is non-viscous, incompressible and irrotational. These are the assumptions of Bernoulli. Exactly, very good. And what we can say about this equation? This is for, simply we can say it is for ideal fluid. So when we say ideal fluid, automatically ideal fluid is steady, inviscid, which is non-viscous, right? Incompressible and irrotational. We can also say it is for ideal fluid. Next. So assertion reason type question can also appear in the exam. You can see assertion is given as the coefficient of discharge of a venturi meter is higher than that of a orifice meter. So if you know what is coefficient of discharge, if you talk about venturi meter, the coefficient of discharge will be around 0.95 to 0.98. This is coefficient of discharge for venturi meter, and for the case of orifice meter it is 0.68 to 0.74. What is the relevance of this coefficient of discharge? So generally these devices, that is orifice meter and venturi meter, they are used for finding the discharge. Now discharge that you calculate by using these devices, they give you which kind of discharge? They give you theoretical value of discharge. They give you theoretical value of discharge. But to find the actual discharge, you have to multiply with a factor which is called coefficient of discharge. Then you will get the actual discharge. Now this coefficient of discharge depend on the losses, right? Hello Gurdat, good evening. They depend on the losses due to friction. Okay, this coefficient of discharge depend on losses due to friction. The first statement is the COD, that is coefficient of discharge of a venturi meter, is higher than that of orifice meter. This is absolutely true. This is true. And what is the reason in support of this assertion? Reason is orifice meter produces eddies and cross current in the fluid flow which dissipate the energy. The reason why the coefficient of discharge is less for orifice meter is because when the flow takes place from orifice meter, suddenly there is a large pressure drop due to a minimum area which is called vena contracta. So there is a very large amount of energy loss take place, which is absolutely correct. Okay, and that is why both the statements are correct. Both A and R is true and R is a correct explanation. R means reason. Assertion and reason both are true, and reason is a correct explanation of assertion. Are you able to understand the meaning of this statement? That whatever statement number 1 was there, statement number A was coefficient discharge of a venturi meter is more than orifice meter. And the reason in support of the assertion is because orifice meter produces eddy current. Eddies means, if you see the orifice meter design, in orifice meter suddenly what happens, a vena contracta comes, a minimum area comes, And just after the vena contracta, what happens? Sudden expansion take place. What happens? Sudden expansion. And because of that, this is the eddies. These are the eddies formation take place in this region. And this eddies formation leads to lot of energy loss. And because of the energy loss, in orifice meter, coefficient discharge is less. Hi Kuldeep and Gautam, good evening. Welcome to the session. Which of the following correctly represent the shear stress distribution across a section of a circular pipe having a viscous flow? Hope you all know that when we say viscous flow, we are talking about laminar flow, because laminar flow is a type of a flow which is basically characterized as a flow which is having more viscosity and less velocity, right? That is called a laminar flow. While the other type of flow is called turbulent flow, which is having less viscosity and more velocity, right? So viscous flow is nothing but laminar flow, and you have to tell which is the correct representation of shear stress distribution. So if you see a circular pipe, and there are two types of distribution we see in the circular pipe. One is called velocity profile, one is called shear stress profile. Velocity profile generally for the laminar flow is a parabolic type. It is parabolic velocity distribution, velocity profile. While shear stress is a linear type. This is a linear type. And if you see the linear distribution of the shear stress is zero at the center of the pipe. While if you see at the wall of the pipe, you will find the shear stress become maximum. It becomes maximum at the wall of the pipe, while it is zero at the center of the pipe. While it is not true for the velocity. Velocity is maximum at the center. It is also called center line velocity. Clear? So this is the distribution. Now what is the relation? Tau is equal to shear stress is equal to minus of del P by del X. This is also called as pressure gradient into R by 2. Okay, this is the relation. So what is the right answer for this question? Option number C. Clear to everyone? A pipe of diameter D conveying a discharge Q is to be replaced by two parallel pipes of smaller diameter small d. So basically it is a case of pipes in parallel. So when we connect the pipes in parallel, our objective is, why we connect pipe in parallel connection? To increase the discharge, Discharge will increase while the head loss will be same. So that is the objective of using the pipes in parallel connection. Clear to everyone? Is it clear? Now if you see this configuration, that one single pipe is divided into two parallel pipes of smaller diameter, which is small d, and that single equivalent pipe is having diameter of, that means two pipes which were basically branch pipe, and they have been basically converted into a single pipe. So what is the ratio? The relation is d by d is equal to n 2 की power 5. This is the relation you must have studied. If parallel pipes are connected, having same diameter and same length, in that situation this is the relation you get. What does n signifies here? N means number of pipe. Directly you can use this relation. N means number of pipes. Okay, this is a simple trick. See, I can see the strength in the class is drastically reducing अगर आप ऐसे ही करेंगे. So I know that most of you must be thinking, sir, this technical classes are not important right now, because if you are preparing for RRB JE, CBT1 is important, and for CBT1 we'll only study non-tech, right? But let me tell you one thing very frankly, that same mistake you do for SSCJE also. For SSCJE you generally study technical part, you don't study non-technical part, and this is the reason you are not able to qualify SSCJE every time. I must tell you one thing, that we should take both the classes together, right? We should prepare for both the technical and non-technical part, because just after CBT1 will be over, whose marks will not be included for merit of RRB JE. Then ultimately you have to study for CBT2. And let's say you will get only 2 months time. In 2 months time, it is not possible to complete the entire syllabus of CBT2. So that is the reason you have to simultaneously study both CBT1 and CBT2. So those who are making this and thinking that we'll only study CBT1, let's first clear CBT1, then we'll study CBT2. Don't make this mistake, I'm telling you. So number of pipes, how many pipes? 2 parallel pipes. So just put the value 2 here. So it will be d by d will be equal to 2 ki power 2 by 5. 2 ki power 2 is equal to 4. 4 ki power 1 by 5. So this you will get this answer. Clear? Next question. Match list 1, which is the list 1 is containing physical properties of the fluid, and list 2 contains the dimensions or definition. You have to just do the match the following type questions. This kind of question you will also find in the exam. Absolute viscosity, which is also called as dynamic viscosity. What is the other name? दोनों मैनेज नहीं हो पा रहे. देखिए थोड़ा सा टाइम टेबल ऐसा बनाओ अपना, ठीक है. ट्राई टू मेक दिस काइंड ऑफ टाइम टेबल दैट लेट्स से यू मेक अ टाइम टेबल फॉर 6 hours. Okay, I'm telling you study 4 hours of non-technical. Give 4 hours of non-technical if you are preparing for RRB JE. But out of the 6 hours, at least 2 hours should be spent for technical. Because ultimately you don't have to get 100 out of 100 marks in CBT1. You just have to qualify it. And for qualifying it, you need to get 60 plus marks. You can easily qualify it. Or maybe 70 if you are applying for that zone, which maximum cutoff will be 70, not more than that. So easily you can manage it. Absolute viscosity, CGS unit is poise, right? Kinematic viscosity, CGS centimeter gram second unit is Stokes. So you can easily match it. For A it will be 3, for B it will be 5. A3, B5, A3, B5, option B and D can be the answer. What about the surface tension? Surface tension is Newton per meter, that is this. So option D will be the right answer. And you know about Newtonian fluid. Newtonian fluid is that fluid which follows the Newton's law of viscosity, which says that tau is equal to mu du by dy. This is the equation for a Newtonian fluid. The fluid which follows this equation, that is called as Newtonian fluid. Okay. If the diameter of a capillary tube is doubled, the capillary rise will become. If diameter of the capillary tube is double, see there is no reason for you to leave the session because it is only for 1 hour. That is the reason we understand the importance of non-technical initially. This is the reason we are only providing one technical class from mechanical and one from civil. And where the subjects are common like SOM and FM, there we are only providing one class. So we are already providing you only one classes for technical, right? We understand that this is the time for studying non-tech, but technical should also go hand in hand. So we know the formula for capillary rise, that is equal to H is equal to 4 sigma by rho GD. So this is the formula for capillary rise, where cos theta is also there, but if we are talking about capillary rise in the case of water, capillary rise takes place for water where theta becomes 0 degree, then cos 0 becomes 1. In that situation, this will be the equation for capillary rise, that is 4 sigma by rho GD. है ना? ये हो जाएगी equation. This is the equation. Hello Ramjeevan, good evening. Now you can see the capillary rise is inversely proportional to the diameter. So it is very obvious, if the diameter is double, then capillary rise will become half. Simple logic. Logically you can solve this question, right? Next, when a flat plate of 0.1 meter square area is pulled at a constant velocity of 30 centimeter per second parallel to another stationary plate. So there are two plates, okay? There are two plates. One plate is stationary. Let's say this plate is a stationary plate, and other plate is moving with a velocity of 30 centimeter per second. All right. And area is also given 0.1 meters square. And the distance between the two plates is equal to how much distance? This is, let's say, dy is equal to 0.01 centimeter. The dynamic viscosity is given. You need to find the force required to be applied. How much force should be applied? Firstly, we'll apply the Newton's law of viscosity in this situation. So one thing that should come in your mind is which formula should be applied. As you see the question, which formula should be applied? You need to find the force. But how you find the force? You know Newton's law of viscosity, tau is equal to mu du by dy. Right? And what is shear stress? Is equal to shear force per unit area. Right? It is equal to mu du by dy. So shear force is equal to mu into A du by dy. Now here the velocity is 0, here velocity is this. So change in velocity will be equal to what? Du will be equal to 30 minus 0. This will be 30 centimeter per second. dy is also given, mu is also given, and area is also given. Everything is given, just put the values here and you will get the answer. Tell me, mu is equal to how much? 0.001 into 0.1 into 30 centimeter is 0.3 divided by 0.01 into 10 to the power minus 2. Just try to solve this and tell me the answer. Yes, everyone. Pushpin is giving answer is option B and Ram Jeevan is giving option A. Please be careful about the units. Sorry, this decimal places. Velocity should be converted into meter per second, not centimeter per second. Okay, so multiply by 0.3. It is not 30, it should be 0.3 meter per second. Are you all getting option A or option B? Option A, very good. Option A, 0.3 Newton. I am giving you proper time, don't worry. If you think that, sir, we need more time for calculation, you can take as much as time, but try to solve the question and use calculator also, because calculator is allowed for CBT 2 and SSC JE CBT. SSC JE and RRB JE CBT 2. So you can use the calculator also. So if you use the calculator, then you can easily understand that maybe in decimal places you are doing mistake, but the answer will come out to be 0.3. Yeah, it will be 0.3. Yes, absolutely correct. The pressure inside a soap bubble of 50 mm diameter is 25 Newton per meter square above the atmospheric pressure. What is the surface tension in the soap film? After even after using the calculator, I think some of you are giving answer incorrect. Option B is not the right answer. Option A will be the answer, 0.3 Newton. Please check your calculation. So for soap bubble, हिंदी में एक्सप्लेन कर सकते हैं, देखिए करने को कर सकते हैं, बट ऐसा क्या है जो आप नहीं समझ पा रहे हैं हिंदी में, बता दीजिए आप. एक्चुअली इट इज सी as you know that these are all pan-India exams where most of the people will easily understand English, but not all the students can understand Hindi. So the reason why we are taking the classes in English is the same reason that all the people in India understand English but not Hindi. PDF, yes, I have saved the PDF for yesterday class. The PDF will be provided, yes. It will be provided on my Telegram, and my Telegram is Mechanical by Vikas. I have to check that. Let me check. So I will provide the PDF of yesterday's session and today's session on my Telegram. Don't worry. Okay. It is also Resultant A, JE. Resultant A and JE Mechanical. Yeah, the name of the Telegram is Resultant A and JE Mechanical. आप लोग please everyone join this Telegram, and here you will get the PDF of the session. Clear? If you want the PDF, then please join the Telegram. This will be the place where I will be sharing the PDF of the sessions with you guys. Clear? Yeah, I will share the PDF of yesterday's session also, thermodynamics subject. So you know that pressure drop is equal to 8 sigma by D, 8 sigma by diameter. This is the formula that we use for soap bubble, right? Change in pressure is equal to this. So you have to find the surface tension. Surface tension will come out to be change in pressure into diameter divided by 8. This is given as 25, diameter is 15 10 to the power minus 3 and divided by 8. If you solve it, you will get the answer 0.156 Newton per meter. Are you all getting this value? Hi Shiv Kumar, good evening, welcome to the session. Next question is, which one of the following represents equilibrium of a static fluid? मैंने कहा था टेक्निकल नहीं, हाँ मैं I told that I will not be teaching technical now, but for the time being, whenever I'm also planning to do some other things in my life, but till the time being, I thought I should teach my technical knowledge that I have. Okay. So you know that hydrostatic law you have studied. For the static fluid, you have studied hydrostatic law. Have you studied hydrostatic law? So for a static fluid, the fluid which is at rest, what is the hydrostatic law? Do you remember the equation? Hydrostatic law says that the increase in the pressure with respect to the depth is equal to minus rho g. This is the equation that you study. And why the minus rho g sign? What is the meaning of minus sign? Minus signs means, let's say you are measuring the pressure at any point in a static fluid and you are measuring the pressure in the upward direction. If you are measuring the pressure in the upward direction, it will be minus. If you are measuring the pressure in the downward direction, it will be with respect to this free surface. With respect to free surface, if you are measuring the pressure in the upward direction, so for upward direction it will be minus sign, for downward direction it will be plus sign. Okay. So as you know that when you move from the free surface above the sea level, pressure will decrease. If you move below the sea level, the pressure will increase, right? So if you solve this, you will get dP by rho is equal to minus g dz. This kind of equation will come, right? The answer will be option D. Very good. Next is match list 1 with list 2. So here you can see in the list 1, you can see the nature of equilibrium of a floating body. So floating body, when we say floating, it is definitely we are talking about partially submerged body. Partially submerged body. Can you tell me the example of a floating body? Any example of a floating body you have in your mind? Like ships. So you have seen a floating body, right? So ships used to float in the ocean, and that is a perfect example of a floating body. Now there are three conditions: unstable, neutral and stable equilibrium, right? Three conditions are given. Hello Anas Khan, good evening, welcome to a session. Unstable, neutral and stable equilibrium. For a floating body, unstable equilibrium means when the meta center is below center of gravity. Okay, M is what? M is the meta center. So position of meta center plays an important role for the stability condition of a floating body. Meta center position. And what is G? G is the position of center of gravity. Okay, so under unstable equilibrium, the meta center is below center of gravity. Under stable equilibrium, meta center is above center of gravity. And for neutral one, this is called as metacentric height. It is called metacentric height. Third condition they are giving for metacentric height. So metacentric height becomes 0. You know why? Because in neutral equilibrium, M is at G. Metacenter coincides with center of gravity. That is why metacentric height becomes 0. So for A it will be 3. For B it will be 1. A 3, B 1, and so this is the right answer. Clear? Next, which of the following relation must hold for an irrotational two-dimensional flow in the XY plane? Now we know that for a flow to be irrotational, for irrotational flow, we all know that for irrotational flow, vorticity should be 0. So vorticity is equal to curl of velocity vector, and curl of velocity vector is also called as cross product of velocity vector. Cross product of velocity vector. So let's say if you want to write the cross product of velocity vector, this will be equal to, cross product of velocity vector will be equal to I j k del by del x, del by del y, and del by del z, u v w. You know how to find the cross product. So if you find the vorticity in the z direction, it will come out to be this, del v by del x minus del u by del y equal to 0. This is the, if you find the vorticity symbol is this. In z direction, it will be come out to be, if you see z direction, this will be del v by del x minus del u by del y, del v by del x minus del u by del y equal to 0. If this comes out to be 0, that means this is basically case of irrotational flow. Clear to everyone? Those who are giving option A as the answer, that is not correct. If you are finding the vorticity for xy plane, xy plane means you are not finding it for z plane. So you will ignore the z1, multiply with this, cross multiply with this, del v by del x minus del u by del y, okay, equal to 0. This will be the answer. Clear? This is how you find the cross product. Clear to everyone? Any doubt on this? Please tell me. That is why I have shown you how to find the cross product, because most of you are giving the wrong answer. Why are you giving option A as the answer? Yes. What mistake are you doing? Next, which of the following statement is correct? A steady flow of diverging straight streamline. Diverging straight streamline means, so this is a streamline, but it is a diverging one. So these are the streamline, diverging one. So if you see this diverging, when the passage is a diverging passage, that means convective acceleration will be there. Convective acceleration means depends on the position, depends on space coordinates. It depends on the space coordinates. So it will represent. But for steady flow, local acceleration which depends on time factor, it is 0. Okay, so this type of fluid will only have convective acceleration. It will have convective acceleration. Yes. Now, which kind of convective acceleration it will have? It will have convective normal and tangential, or only have tangential or normal, because this will not be the answer for sure. This will not be the answer. So if you see in the case of convective one, if you see the fluid will be moving in this direction also, it will moving in this direction also. In both the direction the fluid will be moving, so it will be having normal or tangential. Tell me. It will be experiencing what kind of acceleration? Think about it. And guys, I hope you guys are enjoying the session. If you are, then please do not forget to like and share the session also. Okay. Do not forget to like and share the session. I think there's some problem with my internet. Just a second. Any problem with the internet? So the right answer will be option number C. It will only have convective tangential acceleration. What is the meaning of convective tangential acceleration? That means the fluid is only changing in the velocity in the direction of the flow. Okay, so the flow is the velocity is only changing the direction of the flow. That is why it will be having tangential acceleration, not normal acceleration. So normal acceleration will not be present. So because the fluid is only moving in the straight streamline. Because the fluid is moving in straight streamline, it will not have normal acceleration. It will only have tangential acceleration. In convective, it will only have tangential acceleration. No, local acceleration does not mean normal. It means local acceleration is also called temporal acceleration, not normal acceleration. Temporal acceleration. That is different. See, normal is different. What is the meaning of normal? See, tangential means in direction of the fluid flow. In direction of fluid flow, when you are seeing the acceleration direction of fluid flow, that is tangential. Normal means perpendicular to direction. Perpendicular to direction of the fluid flow, if you are saying this. Okay, direction of fluid flow. So because the fluid is moving in a diverging passage but in straight streamline, so it will not be having normal convective acceleration. It will only be having tangential convective acceleration. Clear? Option C will be the correct answer for this particular question. Clear to everyone? Moving on to next question. A liquid of specific gravity 0.82 flows with a velocity of 4.43 meter per second. What will be the velocity head? So velocity head is also called as, it is having so many names: kinetic head. It is also called as dynamic head. You can call it by any name. So how you find this velocity head, kinetic head, dynamic head? It is equal to v square by 2g. In this particular case, velocity is given 4.43. Just make a square of this. 4.43 into 4.43 divided by 2 into 9.81. Just solve it, you will get the answer. Tell me what value you are getting. You can also use calculator. You will get exactly 1 meter. You will exactly get 1 meter velocity head. Clear? So the right answer will be option number A, 1 meter. Next question. State whether the following flow field is physically possible. The flow field is physically possible. How to find that? The flow is possible. The flow is possible. When this is asked in the exam, flow is possible, then you have to satisfy the continuity equation. Continuity equation. Okay. So continuity equation is basically del u by del x plus del v by del y equal to 0. Just find this. If it is equal to 0, that is true. And this continuity equation is only valid for steady and incompressible flow. It is valid for steady and incompressible flow. So just find this. Del u by del x will be equal to 3y square plus 2. Del v by del y will be equal to minus 2 minus 3y square. Okay, if you solve it, you will get 0. Because you are getting this value 0, if you put it here, it is a case of steady incompressible flow. It is possible only for steady incompressible flow because this equation is only applicable for steady incompressible flow. Clear? Is it clear to all of you? Tell me. Next question. A triangular notch is more accurate measuring device than rectangular notch. See, notch, this question have particularly taken for civil branch students. If anyone is from civil branch, then this is notch. Notch and wear is in their syllabus. So that is why I have taken this particular question. Most of the topics are common in mechanical and civil, but few topics are there which are not present in the mechanical but only for civil, which is notch and wear. Triangular notch is more accurate at low flow rate as compared to rectangular notch. Okay, so remember this. Which of the following expresses the hydraulic diameter? So this is something which is comes under topic of open channel flow, and open channel flow is only for civil. Those who are from civil branch students, because it was told to me that whenever there will be common subject, SOM and FM, so they will be common for both civil and mechanical. Okay, so there will be only one class. Generally, we'll be providing two classes for civil mechanical, one for civil, one for mechanical daily. But when the subjects will be common like SOM, FM, then there will be only one class. Like today, there is only one class of civil, of technical. Okay, it is common for civil mechanical. So the right answer for this question is option number C. You know what is the hydraulic diameter? So hydraulic diameter is equal to 4 into area divided by perimeter. This is called wetted perimeter. For a case of a rectangular pipe, area is equal to 4 into area is equal to A into B. Let's say rectangular pipe is having width B and height is given as A. Perimeter will be equal to 2 into area, one side plus 2 into B. So this will be come out to 4AB divided by 2A plus B. If you solve this, you will get this value as 2AB by A plus B. Clear? Option number C will be the right answer for this question. What is P? P in this particular case is called wetted perimeter. It is called wetted perimeter in case of open channel flow. Clear? Next, the rate of flow through a V notch is proportional to which of the following? For V notch, rate of flow is proportional to, so there is a formula. I exactly don't remember the formula, but we know that the discharge, which is also called rate of flow, for case of a V notch is directly proportional to head the power 5 by 2. So this is the equation. There is a typical equation for this, and I exactly don't remember the equation right now, but this is the relation between discharge and head for V notch. Next question. The boundary layer thickness at a given distance from the leading edge of a flat plate is. So what is the meaning of boundary layer thickness? So let's say we have a flat plate, and over this flat plate, a free flowing fluid is about to flow over this flat plate. It is having free stream velocity of V infinity. As soon as this fluid starts to flow over this flat plate, then immediately over this flat plate, a boundary layer starts to develop. A boundary layer starts to form. Inside this boundary layer, you will find the velocity gradients are present. What are present? Velocity gradient are present. And the height of this velocity gradient, or this is nothing but this is the thickness, boundary layer thickness. Leading edge. What is the leading edge? This is called as leading edge of a flat plate, and this is called as trailing edge of that plate where the plate ends. That is called trailing edge, the other end of the plate. So boundary thickness at a given distance from the leading edge of flat plate is more for lighter fluid. So how can you tell it is more for lighter fluid or less for lighter fluid? How can you tell that? Yes. Boundary leading edge of a plate, the boundary thickness is equal to 5 into x by the square root of Reynolds number. This is true for laminar flow. If it is a laminar flow, this is a relation. And as per this relation, my friends, the boundary layer thickness is equal to 5 into x square root of Reynolds number is equal to rho V infinity into x by mu. So if you see, the boundary layer thickness is inversely proportional to square root of density. Are you getting this? Now, it is very obvious. It is directly proportional, inversely proportional to square root of density. So boundary edge thickness, initially you know that it is very less. Leading edge of a flat plate. So what will be the answer? What should be the answer for this question? What relation you find? Yes, it is more for the lighter fluid or denser fluid. How can you tell that flow is a lighter or denser fluid? Tell me. Which factor will tell the flow is a lighter or denser? So they are asking boundary edge thickness a given distance from the leading edge. Given distance means x is same. If x is same, then if this is less, this will be more. So boundary edge thickness at a given distance from the is more for lighter fluid. It is more for the lighter fluid. If it is lighter fluid means, see, lighter fluid means less density. Less density. Density, no, density. If it is less dense, it will be lighter fluid. If the density is high, it will be. So if the density is less, it will be this boundary edge thickness is more. So it will be more for the lighter fluid. So option A will be the right answer. X is same. What is this distance? This X is same because at a given distance from the leading edge, given distance means X is kept same. So this is inversely proportional to the density. Clear? Next question. In case of a laminar flow, the loss of pressure head is proportional to. Have you understood the question or not? Tell me, everyone. Understood the previous question? Laminar flow, the loss of pressure head. See, loss of pressure head is pressure head per unit specific weight, that is equal to 32 mu VL by rho G d square. So this is basically loss of pressure head for laminar flow. For laminar flow, this is a loss of pressure head, and that loss of pressure head is proportional to velocity, square of velocity, q velocity, half of velocity. It is proportional to velocity. It is just proportional to velocity. Neither it is proportional to square or q. So v is the velocity here. So this is the velocity. It is just proportional to, directly proportional to velocity. Next, velocity for flow through a pipe measured at center is found to be 2 meters per second. Reynolds number is around 800. What is the average velocity in the pipe? So if it is a, let's say Reynolds number is equal to 800, and if it is a pipe flow, then if Reynolds number is less than 2000, it is a case of laminar flow, right? It is a case of laminar flow. And for laminar flow, we know that this is the last question, my dear. Okay. And in this session, I have gone little bit slow, only for those students who are studying fluid mechanics from after a long time. So I am trying to explain each and every question rather than just giving that this is the question, this is the answer. Okay, so we can do that, but that in that way you will not understand the question. You will just, those who know the answer, they will say yes, answer is A, answer is C, right? But those who want to understand the concept, for them I am going slow. Okay, so maybe we have not covered much question today, but objective was to understand the concept. For laminar flow in the pipe, we know that the velocity profile will be parabolic velocity profile, right? We have discussed that the velocity profile will be parabolic type. And what is the meaning of parabolic velocity profile? The meaning of parabolic velocity profile will be that at the center of the pipe, the velocity will be maximum, and at the center it is equal to 2 meters per second. And for laminar flow in the pipe, the average velocity is equal to half of maximum velocity. Okay, So this is the answer, option number C. Clear? Clear to everyone? And let's take this as the last question. Liquid has a specific gravity of 1.9 and a kinematic viscosity of 6 torques. What is the dynamic viscosity? It looks like a very simple question, you know. If specific gravity is given, kinematic viscosity is given, dynamic viscosity you have to tell. Dynamic viscosity is equal to mu, it is equal to what? Kinematic viscosity into density, right? So kinematic viscosity is given as 6 torques. 6 stoke, you know what 1 stoke is? Conversion of unit is also important. 1 stoke is equal to 10 to the power minus 4 meter square per second. Okay, so it is 6 into 10 to the power minus 4. Okay, now what is specific gravity? Specific gravity is given. If you know the specific gravity, you know that specific gravity is equal to 1.9. It is equal to density of that particular fluid divided by 1000. Here you can find the density. Density will come out to be 1900. So just multiply by 1900, you will get the answer. Tell me what is the answer you are getting. This is the last question for today's session. Tell me everyone. If you have any problem in understanding it, you can tell, just let me know. So if you solve it, you will get 1.14. Okay, that will be the answer for this question. And that's all, my dear, for this particular session. I hope you all have enjoyed today's session. Rest of the question which are left will be covered in some other session. I always take some extra questions for the session, so that see, I can also take the session in a fast forward manner, like a bullet train. I can also in terms of railway RRB, I can say that I can also take this session in the Shatabdi manner or Vande Bharat manner. But the reason I am going little bit like in the express form right now, because it's trying to build the concept, not to run like a super fast train. So the reason I have gone little slow and taken, let's say I have taken 10 less question in session, was to make you understand the concept. I hope you have understand each and every question. And it's not that it, because generally if you see in the YouTube, some people say that it's just a matter of, you know, people come and they give the answer. Those who know the answer, they say A, they say B, C, D, but that's all. But I don't believe in that. I believe that if you are coming the session, you should, even if it is a practice session, you should when you go from the session, you should think that today you have learned something. Okay, आज कुछ सीखा हमने, ऐसा नहीं कि you have just spent your time and just it is a kind of a quiz. Okay, so please everyone, I request all of you, yes, class will be daily but not mine. Tomorrow will be class of, I think, Suraj sir. Okay, I have taken, now I will be, my next class will be, my next lecture on Monday. But it's not that classes are only, if you want to attend my classes, or next class will be on Monday, but tomorrow there will be mechanical class of Suraj Gopi sir. So tomorrow there will be class of Suraj sir, and that will be on heat transfer. So he will be taking the heat transfer, then followed by mechanics, I guess. So that's how the classes will be taken. Clear? Let me tell you the name of the telegram. What is the name of the telegram here? Yeah, it was Resultant AE and JE Mechanical. So if you want to download the PDF of today's session, Resultant AE and JE Mechanical. So this is the name of the telegram. Please follow this telegram for the PDF. Okay, and please subscribe the channel if you have not done it yet. Thank you so much everyone for joining me for this session. Have a very nice day. I will see you on Monday, but tomorrow, see, every day, and also daily 8 p.m. every day from Monday to Sunday. Monday to Sunday daily class will be conducted for mechanical. Okay, it's not that see, my classes will be, let's say, 3 days a week, but other faculties, that is other subject, will also be, should be conducted, right? Like Suraj Gopi sir will be taking the subject of heat transfer, mechanics and other subjects, followed by Dheeraj Sardana sir will be taking subject of productions, production material science. So daily you will find the classes. It's not that they will be off on 2 days. Daily you come at 8 p.m. you will find the class, okay, on this channel. Clear to everyone? Is it clear to all of you? But I will see you on Monday. My next class will be on Monday. Okay, that's all, my dear. Thank you so much. Take care. And thank you so much everyone for joining me for the session. If you have not liked the session, then please to hit the like button, share the session, and please subscribe the channel if you have not done it. Thank you so much. Have a nice day.